Hello all, welcome to this online seminar on SewerGEMS. Myself Tanay Kulkarni, I am a technical consultant for water and I'm based out of Bentley's Pune office. Uh, I am a big data certified from Massachusetts Institute of Technology, masters in hydraulics and a graduate of civil engineering. Uh, Bentley solution offerings consists of a wide range of industries, right from water, wastewater, buildings, campuses, oil and gas, power generation to communications, rail transits, uh, utility networks, etc. So out of these four verticals, we have our water and wastewater offerings like this that you can see on the right of the screen. In water, we have water distribution systems, network analysis and designing software, SewerGEMS, surge and transients analysis software, which is Hammer. For wastewater and stormwater, we have StormCAD and SewerGEMS. And for GIS applications, we have Bentley Map. And for publishing the GIS files information to web, we have GeoWeb Publisher. SewerGEMS V8i is an urban sanitary and combined sewer modeling and management software. SewerGEMS comes as a standalone with its own platform. It can also be integrated completely with MicroStation, AutoCAD and ArcGIS. That means you can use SewerGEMS from within ArcGIS or from within AutoCAD or from within MicroStations. So this is the product hierarchy. SewerGEMS is a superset of StormCAD, CivilStorm and SewerCAD. So basically it's a combination of four different softwares. So it's a combination of four different engines: implicit dynamic wave engine, explicit EPA swim engine, GVF convex engine, which is the engine for SewerCAD, and GVF rational engine, which is the engine for StormCAD. Like I said, you have two dynamic engines which follow Saint Venant's equation. One is implicit Bentley implicit engine and the other one is explicit EPA swim engine. Now these engines are used for calculations of storm based on time, which follows SCS methods. You can utilize unit hydrographs or even modified rational method using these engines. Now SewerGEMS dynamic wave solver does fully dynamic routing. It also understands combined sewer overflows, or you can do infiltration and inflow studies. You can analyze complex hydrology conditions using dynamic wave solver. Swim engine is used for it's available over there for compatibility with older swim models. You can do water quality analysis or long-term continuous simulations like groundwater infiltration and all. SewerGEMS GVF convex model is used for SewerCAD engine. For sanitary wastewater collection systems analysis network design. It consists of two types of analysis. One is steady state and the other one is extended period simulation. Steady state is basically done to understand the capacity of the network for peak hour durations or peak max day condition. Now you can also design this entire system or a subdivision of your network using automatic designing algorithms in SewerCAD, which will give you the invert levels of the optimal invert levels of the manholes and optimal size of the pipes. Now you can also use peaking factor based on CPHEO, and you can uh, stress your network and subject the network design under constraints of velocity, cover, etc. Now in SewerCAD you can also do tractive stress calculation, which will help you understand uh, and uh, and finalize the pipe sizes in order to avoid sedimentation, and it converges the solutions very quickly, so you get very fast solutions using SewerCAD engine. Now that is that this is what steady state is used for. SewerGEMS Sanitary extended period simulation is used to understand the pump system uh, operations, how when the pump should start or when the pump should stop, what will happen if you operate your pumps under various situations. Now you can also do diurnal variations, that is how the loading is fluctuating over a period of 24 hours. You can do the wet well sizing. GVF convex engine will allow the modeler to use these elements. You can insert a manhole, pump, variable speed pump, battery, or wet well, conduit, outfall, pressure junction, pressure pipe. This is how we do a typical modeling. So the data required is the ground elevations, the invert elevations, and the sanitary loading on each of the manhole. For pipe, the data required is the length of the pipe, what is the Manning's N, and the diameter of the pipe, and what is your boundary condition for the outfall, whether it's a free outfall or you have some tailwater conditions at the outfall. And the output, it will give you the depth of water in the conduit, the velocity of water in the conduit, and discharge through each and every conduit. Using SewerGEMS, you can automatically design the network for optimal sizing of the pipes and for optimal depth of excavation, that is optimal invert or invert level of the manholes. You can not only use SewerGEMS for sanitary loading, but you can also consider inflows and infiltration under wet weather loading, and then you can model it and analyze your network for inflows and infiltration in the network. Using SewerGEMS, you can analyze gravity networks, but you can also do pressurized network analysis, like in the case of a rising main or a pumping main. Now let us take a look at the GVF convex engine in SewerCAD, and how is it used to automatically design the network, the sanitary sewerage network. First of all, there will be a tool which is called as default design constraints. This is the place where the modeler can define the constraints, the velocity constraint, cover constraint, or slope constraint. And for nodes, it can be you can stress or constrain your network for pipe matching inverts or crowns, and you can also specify whether you are looking forward to having a drop structure in the network design. Now you can also do partful design, where you can specify you are designing the network for 80% full or 70% full. You can specify the number of barrels in the conduits, and you can also limit the section size. Now let us take a look at the loading, the dry weather loading and wet weather loading, and how we can do it using SewerGEMS. Uh, in SewerGEMS, you can assign loads to the manholes depending on the area, uh, depending on the count, that is the population, the discharge, that is if you know the exact value of flow at every manhole, you can do it, you can assign that flow to that manhole individually, You can assign the loads on the manholes depending on the population, and there is a tool which is called as Sanitary Load Control Center, which helps us doing or loading the sanitary network. For wet weather loading, we can assign unit hydrographs. Just sorry. For wet weather loading, you can assign unit hydrographs, or you can use the curve number for uh, assigning the storm loads to the manholes. Uh, at the same time, you can also assign local storm events and global storm events. Uh, for inflows or illegal connections, you can use inflow control center. There is also a tool which is called as model builder, which will help you leverage virtually any data source and create a hydraulic model. So you can create a sanitary network using the drawings, the CAD drawings that you have, or Excel sheets that you have, or GIS data that you have, right? And you can create a SewerGEMS network. You can extract all that information and create a data model. There is a tool which is called as load builder, which will help you assign assign sanitary loads uh, to manholes automatically. So instead of doing it manually, you can automate the process of building loads and assigning loads to the model using GIS information that we have, right? So there are various types of distribution methods that are available. You can uh, use this tool to load your sanitary model. There is a tool which is called as terrain extraction tool. It is called as T-Rex. It's used to automatically assign elevation to the model. So if you have any data from either a shape file or a contour DXF file or DTM or DEM, you can extract that information and load the elevation to your hydraulic model automatically using this T-Rex. Now another important feature in SewerGEMS is scenario control center. Using scenario control center, you can model unlimited what if situations. So if this is your current scenario, right? If this is the current network, your current sanitary network, if you want to see what will happen if you forecast the expansion, the southern expansion in 2010, for example, right? Now, if you have additional service connections in the southern part of your network, will the existing infrastructure be capable of catering the additional flow? If not, then what should be done, right? If by the year 2020 you anticipate northern expansion in the city, and if you join the northern expansion to the existing infrastructure, will that system be capable to adequately adequately convey water to the sewage treatment plant, right? If not, then will the new diameter be helpful for the expansions? So unlimited scenarios you can create model, and this helps the modeler to understand the network over various scenarios, and take fine decisions depending on the hydraulic proof that we get using these scenarios. So now if you have a GIS wastewater model, you create the model using model builder and you have a SewerGEMS model, right? So on day one, both the databases will be in sync, both the GIS file and the model. Now the GIS team may work for, let's say, 3 months on that model, and at the same time the hydraulic team may work for 3 months on the sewerage network, right? So both the teams are working in silos, right? So both the GIS file and the SewerGEMS file won't be in synchronization, but using model builder you can synchronize both the GIS file and the SewerGEMS file after any duration of time, right? So you can do wastewater model synchronization, and you can see the results and output of SewerGEMS after computing the network. Either you can color code the network like this, you can annotate the network for various properties like the d by d ratio, or or the label of the conduit, the size of the conduit, right, the length of the conduit, and the manholes for the HJL or the invert level or the ground level, so on and so forth. And you can create flex tables like this, wherein you will get all the results in tabular format, and you can create graphs for the storm event or the flow in the conduit, right? And you can compare the graphs for a particular element over various scenarios, and you can create profiles like this, right? There is much more about SewerGEMS, and you can explore more about the product on our website www.bentley.com. You can find case studies at www.bentley.com/WTR, and I recommend you to join our online community at communities.bentley.com.
Now let us see a small sewerage network in SewerGEMS. So this is how it looks like, SewerGEMS. Here I have taken a background AutoCAD image uh, for a reference to draw my network. All the network is scaled. Now let us take a look at the manhole flex table. Now we are assuming here that this network is an existing network, and hence we have the invert elevations of the existing manholes. Now let us take a look at the conduits. In conduit flex table, we have all the properties of the conduits which are existing in the system. So we have PVC circular conduits of 100 size, and we want to design a new system or rehabilitate the existing system. Now there is a tool which is called a sanitary load control center, which is used for assigning the sanitary load to the manhole. Now, as in this case, we have a unit sanitary load which we called new residential, and let's take a look in it. So we have uh, this many liters per day sanitary loads for 3 persons per residence. So this is how we have used unit sanitary load control center. Now let us go to analysis and compute this existing network. Now once we compute the network, it will give us a list of user notifications and a calculation summary. Now let us color code the network for flow through the conduits. And let us see if any of the manholes in the existing network is overflowing. So once we check it, so it will show us the manholes which are overflowing in red. So these are the manholes which are overflowing, and the green manholes are not overflowing. Now let us take a look at the profile. Now if you observe, this manhole MH5 is completely overflowing as the HGL raises above the ground level. The ground level is green in color, the HGL blue in color. Let us take a look at another profile. See, the pipes are surcharged and the manholes are overflowing. Now this is about the what's happening in the existing network. Now we want to design this network, redesign it for the revised sanitary loads. Now let's go to alternatives and create a new physical alternative so as to register all the physical changes after the design, post design. We'll also create a new design alternative because where this is the design alternative is where we are going to specify our design constraints. Now our default design constraints can be specified in this tool. The constraints can be laid for velocity, cover, and slope. And then we'll go to alternatives and we'll open this design alternative. In this design alternative, we can specify our local constraints for that particular design alternative, like in this case. And now we are going to use this alternative for a design scenario. Like in this case, you can specify local constraints or global constraints. So a couple of pipes are having local constraints. The rest of the pipes are having global constraints. Same goes true for the case of manholes. And now let us use this scenario in which we have used the new physical alternative and the new design alternative. I'm going to make this scenario as my current scenario, and then I'm going to compute it for designing it. It will ask me if I want to use any new alternative for registering all the physical changes. I would say no. So after design, it has given me the summary, calculation summary. What is the maximum velocity achieved? What is the d by d ratio? What is the flow maximum in the conduit? So on and so forth. What is the HGL at the manholes? And it hasn't given me any user notification. If I see all the manholes are color coded for overflows, none of my manhole is overflowing. Let's now take a look at the profile. See, none of my manhole is overflowing, none of my conduit is surcharged. So this is what we have achieved after the design under constraints. This was the base scenario wherein we had a couple of manholes overflowing. This was the profile then, and after designing, we got a new system where none of the manholes were overflowing and the profile looked like this.
Thank you very much for your time. I hope that this online brief overview uh, explained a bit about the software. If you have any queries, please do not hesitate to reach out to us. Thank you very much.